Hello, I'm Percy. We will learn about electricity basics. In this video, we will have a connecting wire, battery, bulb, switch, and a plug key. We can connect this either in series or parallel. Suppose, in this case, there are 3 bulbs connected in series. Can you believe that? If yes, we connect this with battery and a switch. So, let's turn it on. As a result, the current flows as the circuit is complete. Now, if any one of the bulb is blown, the 2 of the bulbs will not light up in series. Now, in the second case, suppose 2 bulbs are connected in parallel. They work together as well. But if any one bulb is broken, other bulb is still glowing in parallel series. That's how the system works. Now, we go ahead and replace the bulb into resistor. Resistor is an electrical component that reduces the electric current. The resistor's ability to reduce the current is called resistance. Thus, it generates heat. You can depict it as a zigzag symbolically. Now, moving ahead to check dimensional formulas of units. We will consider these units. Volts, denoted by V. Amperes, denoted by A with variable I. Resistance, denoted by R measured in ohms. And watts, denoted by W with the help of power. Beginning with this voltage unit, came from the Italian physicist, Alessandro Volta, 1745 to 1827, who is credited as the inventor of the electric battery. How do we derive the units of volts? We have joules per coulomb. Joules can mean Newton meter, that is Newton meter per coulomb. The dimensional formula will have 4 types of units: m, L, T and I. M represents the mass, L represents length, T represents time, and I represents the electric current. The dimensional formula becomes m, L, T to the 3rd negative power, and I to the 1 negative power, depending on the exponents where units multiply. If the exponent is negative, then we have inverse of units to multiply. Dimensional formula can also be used in motion dynamics, compared to electrodynamics. Next, in terms of amperes, came from the French physicist André-Marie Ampère, 1775 to 1836. He was one of the founders of the science of classical electromagnetism, which he referred to as electrodynamics, such as solenoids and electrical telegraphs. Ampere is used in the units of electric current, denoted by variable I. The dimensional formula is I to the 1 power, other exponents are 0, because other units are independent, which will be equal to 1. Next, the resistance, came from the German physicist, Georg Simon Ohm, 1789 to 1854, began his research with the new electrochemical cell, invented by Italian scientist Alessandro Volta. Using equipment of his own creation, Ohm found that there is a direct proportionality between the potential difference, voltage, applied across a conductor and the resultant electric current. This relationship is known as Ohm's law. There are 4 subunits of ohms, following its parameters. A ohm, equal to centimeter per second, its dimensional formula is L with exponent 1 and T with exponent -1. Its subunit is equal to 10 to the -9th ohms. Then coulomb, equal to second per centimeter, its dimensional formula is L with exponent -1 and T to the exponent 1. Its subunit is equal to 10 to the -5th times C squared ohms, where C represents the speed of light. Then Pres, equal to 10 to the 6th ohms. And finally, Planck impedance, a square Planck length times Planck mass per Planck time per Planck charge squared. And finally, watts, came from Scottish physicist James Watt, 1736 to 1819, his fields were mechanical engineering. In terms of power consumption, watts can mean joules per second, then joule means Newton meter. Newton is mass to the exponent 1, length to the exponent 1, and time to the exponent -2. Then multiply by meter, the length will have exponent 2. Then divided by time, we get exponent -3. Its dimensional formula is m with exponent 1, L to the exponent 2, and T to the exponent -3. Except for the electric current. We now covered up everything. Then setting up formulas. We now have one formula of voltage, V, is equal to electric current I, times resistance R. To keep the voltage constant, by increasing the current I, then the resistance R must be lowered, and vice versa. Suppose the current flow is 3 amperes, and its resistance is 1 ohm. What do you obtain in volts? We get a battery of 3 volts. Similarly, you can find the other equivalent formulas like resistance R equals V by I, and electric current I equals V by R. There are 2 cases of resistor connectivity. When you connect it in series, this will add up the resistance. And when you connect it in parallel, this will have inverse addition of resistance. For example, take 2 resistors, 2 and 4 ohms. In series, we get 6 ohms. And, in parallel, we get 0.75 ohms, that is 0.5 and 0.25 ohms of addition. Another formula, for power, P, equals, voltage multiplied by current I. Which is also equal to square of current times resistance R, depending on its heat laws. Please note that the unit is measured in watts. If in case of bigger units, say, kilowatts equal to 1000 watts. Here's an example for you. An electric heater has a voltage of 120 from the mains, and has an electric current of 7 amperes. Determine the power consumption in watts. Therefore, it consumes 840 watts of power. If the power level exceeds the limit, the equipment will result in short circuit, which is dangerous and will be caught on fire. Like, comment, and subscribe.